Hello there! So now that you've been exposed to the concepts and the formulas and kind of the basics of the mean, the median, and the mode, now we're going to get into like the nitty-gritty of when to use which measure of central tendency. So just in case you are having trouble remembering the difference between the mean, the median, and the mode, I have a silly rhyme on the screen and I'll say it even though it's a little embarrassing. Hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. There it is. Now, we didn't focus on the range. The range is more of a measure of variability, which we'll get to in a couple of lectures. But I liked that. I thought it would help you guys remember. Another goofy one is, let me see if I remember it. Mode's the most, average is the mean. Median's in between. There you go. So first, we're just going to go over the different situations that lend themselves to using the mean, the median, or the mode. So depending on the scale of measurement, the shape of the distribution of data, or just in general, the type of question that's being asked about the data, the mean, the median, or the mode are going to be the most appropriate. So the reason we have three different measures of central tendency, because not every single measure works well in every single situation. So for instance, if you have a skewed data set, the mean isn't going to be very reflective of the true nature of the data because those outliers are going to bias the mean towards it. So just thinking about the different decisions that you have to make to land on whether or not you use the mean, the median, or the mode is the best way to describe the data accurately. Then I'm going to take all that information and put it into a flow chart for you that's going to make that decision-making process a little bit more straightforward and easy. So basically just following a path that leads you to which measure is most appropriate. And this is really important in everyday life. If you're ever presenting data, you need to know which way to explain it so that it makes the most sense and that's the most accurate. And if data is being presented to you, you need to be a critical consumer of that. Or if people are telling you the mean and you know you're looking at skewed data, that's probably not the most accurate measure of central tendency. Maybe you could request the median or something instead. Then we're going to look at some examples of distributions and how you would select the most appropriate measure of central tendency, because that's really going to be the basis for your lecture quiz. So before we move on to the decision-making process for selecting the most appropriate measure of central tendency, it's important that you get a little refresher about the different scales of measurement. So remember, discrete versus continuous really gets at whether or not you have whole numbers or categories or true numbers that can be any value, so fraction or decimal. So if you have discrete values, it's whole numbers, it's categories. If you have continuous values, it's something that's truly numeric and that can have fractions or decimals, like age, right? So you could be exactly 37, or maybe you're 37 years, 1 day, 5 hours old. Or if you're looking at your income, right? You're probably not going to report it down to the cent, but there it is implied that it can get down to the cent, right? There's infinite values in between whole number responses. So then so that would be continuous. Nominal is something that's categorical. Values are placed in an arbitrary order. There's no true order about it. So if we were looking at hair color or ethnicity or sex, those are all things that aren't numeric at all. And if you tried to place categories in order, it wouldn't be meaningful. It wouldn't be based on quantity or the numeric order. Ordinal data is something that's typically doesn't look numeric, but it can be. Um, but it's something where you're placing things in a meaningful order based on rank or position, but it's not a truly numeric variable where you could actually like calculate a sum of x for. So a good example of something that it looks numeric, right? Doesn't have an equal distance between sequential values would be like place in a race. So there's not the same distance between first and second place as there is between second and third place, right? There's probably a timing difference between those two, although it looks numeric. So your answer would be no, and you're still landing on ordinal data. Another example would be class standing, right? Freshman, sophomore, junior, senior. Sophomores have been here longer than freshmen. Juniors have been here longer than sophomores, but it's not something that's truly numeric, but it can be placed in a meaningful order. So it'd be ordinal. Interval and ratio are data that are truly numeric. So something that's either quantified, counted, or measured on a Likert scale from 1 to 10, or something that is like truly, truly a number. And the only difference between interval and ratio is this true 0 point. So if there was a 0 for that variable, not necessarily is there a 0 in the data set, but if a 0 is possible for that variable, would that represent a complete absence of what you're measuring? And is there no way you could have negatives? If that's the case, then you're working with ratio data. But think about it, right? So number of children. You cannot have a negative number of children. And if you have 0 children, that's a lack of children. So that's ratio data. But it's also discrete because your values are limited to whole numbers. If I asked you how many pieces of pizza you've eaten today, well, technically you could have fractions or decimals, right? What if you took one bite and put the rest away? So you have something that's truly numeric. You have a true 0 point. If you said you ate no pizza, 0, a lack of it. Can't have negative numbers of pizza, but it would be ratio and continuous because technically you could have a half or a fraction of a piece of pizza. So if you're still confused on this, go back and review the types of data lecture, and we get into explicit detail about this. But it's really important that you understand the scales of measurement. This hasn't gone anywhere because that is going to be the first question that you ask yourself when we decide on measures of central tendency. So again, our decision for the most appropriate measure of central tendency for describing our data is going to be based on the scale of measurement. So is it nominal, ordinal, interval, ratio? Is it discrete or is it continuous variable that we're measuring? Then the shape of the distribution. So we're just going to focus on, is it skewed, negative or positive skew, or is it a normal distribution? Or the question at hand. So again, if you're looking at target demographic or you want to know what item was purchased the most, you want the mode. You don't really have to ask yourself those other questions if the question that you are actually trying to answer lends itself most appropriately to a certain measure of central tendency. Now, this little animation, this little cartoon here gets at the fact that the mean can be totally messed up by outliers. So if we calculated the mean height of beanstalks, this huge beanstalk is going to make that mean go way up and not reflect the nature of the majority of the beanstalks here. So that's just one of the considerations that you make when you're making a selection for measure of central tendency. So the mean is a statistician's first choice. If we can use the mean, we want to use the mean. And there's several reasons why that is. One reason is because the mean allows us to figure out the sum of x if we know how many scores we have. So when we did the weighted mean, you saw that, right? We needed to figure out the sum of x's for each group. So we took the mean and multiplied it by the sample size to get that. So for mathematical purposes, the mean is extremely useful. The mean is also really important because it is the reference point for measures of variability. So when we get to variability and we start talking about something called the standard deviation tells you the typical spread of scores from the mean of all scores. And when we get into calculating z-scores, you're going to see that the z-score just tells you how far away your score is from the mean in terms of how many standard deviations away it is from the mean. So you'll see that we're going to really be focusing on the mean for the rest of the section, but it's not always from a purely descriptive standpoint. If you just want to describe data and not do further calculations with it, sometimes it's not the best choice. The mean is always used in inferential statistics. So if you get into more advanced levels of statistics where you're actually doing hypothesis testing, if you're looking to see, for instance, if a certain training program worked better for, let's say that you're doing on-the-job training versus like video-based training versus no training. So you have 3 groups. And let's say you're measuring performance in those 3 groups to see which training program was the best. Well, you're measuring the mean and you're comparing the mean level of performance across those 3 groups to see if you have a significant difference. In other words, to see if the actual difference that you observed in performance exceeds the difference you would expect to see due to chance, such that to such a great extent that you're confident that those mean differences are due to the training and not due to just some random fluke. So that's like the heart of inferential statistics and hypothesis testing. And again, the decisions about statistical significance are usually based on the mean and then also the standard error, which is based on the standard deviation, which we'll get to later. Now, the mean is only appropriate when you have continuous data on an interval or ratio scale that's either normally distributed, so looking like this, or in a rectangular distribution where all the scores have pretty much the same frequency. If you have a situation with outliers, like if you have a positive skew, these high scores are going to drag the mean towards it and bias that mean so that it no longer really reflects the true trends in your data. Also, the mean's only appropriate when you can actually calculate the sum of x, which is why it relies on an interval or a ratio scale. But it's important to note that even if you start with an interval or ratio scale, but you're given an open-ended distribution, so for instance, if we measured the number of children and the data that we had at hand looked like this, like in a frequency distribution table, the x's were 0, 1, 2, 3, 4, 5 plus, we can't calculate the sum of x because we don't have all of those scores. We don't know what those 5 pluses are. We might have some 6s, some 7s, some 8s. We don't know. It just stops at 5 plus, so we wouldn't be able to use the mean in that case. Also with group frequency distributions, assuming you don't have the raw data, but you're just given like age, right? So age is ratio and it's continuous. But if you're just given a group frequency distribution with that data, it looks like 0 to 19, 20 to 39, right? So on those group distributions, you don't have the raw data to calculate the sum of x, so you would not be able to use the mean in that situation unless somehow you got the actual raw data. So now let's shift our focus to when it's best to use the median. So if you have data on an ordinal scale, go straight to the median. Don't worry about the shape of the distribution. If you're working with those grouped frequency distributions, like I said, like age, 0 to 19 and then 20 to 39, then you would be able to use the median because those values are in a meaningful order. We just don't have the raw data. So the midpoint's still meaningful. We just can't calculate the sum of x. Also, if you have data that's on an interval or ratio scale that has a skewed distribution. So for instance, if we have that positive skew here, or we have a negative skew, this is going to be your mode. Your mean, more than likely, is going to be kind of over here because it's getting drug out by that outliers. But then your nice median is going to be kind of in the middle. And that median is going to really reflect not only the bulk of scores, but also that there's several scores in this situation, a negative skew on the low end or several scores altogether on the high end. So the median is going to be best when you have truly numeric data, interval or ratio, that is in a skewed distribution. So again, a statistician always wants to use the mean if they can, but sometimes they can't. Then the median is the next most preferred, and then the mode is kind of what we're left with in situations where we don't even have data that's truly numeric, or we have like weird distributions going on. So the mode is most appropriate when you either have discrete data that's on an interval or ratio scale, or when you have nominal data. Because think about it, if you have nominal data, there's no meaningful order you can put it in to even find a midpoint, and you certainly can't calculate a sum of x with words, so you're left with the mode. That's the only thing that you can use. And then think about discrete data, right? Discrete data is fixed to whole numbers. So it doesn't really make sense to provide a decimal value, which can happen for the median or for the mean when you're working with whole numbers. So it always kind of drives me crazy when they talk about, like, according to census data, the mean number of kids is 2.2. Well, you can't have a fraction of children. We're not cutting children up into decimals or fractions, so the mode would actually be the most appropriate there. Again, from a purely descriptive standpoint. If you were wanting to do follow-up analyses with that data, the mean is what you would go for. But for now, we're just focusing on pure descriptive statistics. Also, if you have open-ended distributions, the mode is most appropriate because if you have, like number of children, 0, 1, 2, 3, 4, 5 plus, you don't really know how to land on that midpoint for that 5 plus because you don't know what the scores look like. So you're kind of stuck with the mode when you have an open-ended distribution. Also, if you have a situation where you have data that's interval or ratio, and continuous, but you have a bimodal distribution. So if you have a situation where your data looks like this, you're going to want to report these two scores, whatever they are, because that's truly a better reflection of the nature of the data. Whoa, these two scores are happening a lot. You don't want to have something reported here because that's going to make it look like you have a lot of things happening in the center when really you have extremes on either end. There's that. Also, when you want to know what score is most common, so if you're looking at, like, for instance, the target demographic or what item was sold the most, you're going to be looking at the mode, and you're going to kind of forego all those questions about measures of central or about scales of measurement, discrete versus continuous, nominal, ordinal ratio, and shape. Again, if the question at hand lends itself the best to one measure, use that measure. So now let's put all that information together into a nice, easy to use flowchart to help you make these sorts of decisions. So if you have nominal data, go straight to the mode. Don't ask yourself about the shape or anything like that, discrete versus continuous. It's always going to be discrete anyway. Just go straight to the mode. Remember, don't even use this flowchart unless there's not a specific question at hand where a measure is most appropriate. If you're just trying to figure out which measure is most appropriate based on the nature of the data, then this is what you need to use. If you have ordinal data, so data that's categorical or maybe numeric, but isn't truly numeric, where you know not only the direction, but the magnitude of differences among categories, you have ordinal data, go with the median. If you have interval or ratio data, so data that's truly numeric, not only tells you the direction of differences, but the magnitude or the quantity associated with those differences, right? True numeric values, but they're discrete, meaning that you cannot have a fraction or a decimal. So like number of children, number of cars, things like that, then you go with the mode. If you have interval or ratio data that is continuous, but is bimodal or multimodal, where there's tons of peaks there that are meaningful, you still go with the mode. But if you have data that's interval or ratio and continuous, and it's on a skewed distribution, so remember, if it kind of looks like or like this, you go with the median. And then finally, our favorite situation in statistics, you have interval or ratio data that is continuous. It is a nice normal curve. Then you go with the mean. So now let's get into applying these concepts through specific example problems. So if we look at this distribution here, looking at the number of semesters at Nevada State College among a sample of students, we can see that we have a very, very positively skewed distribution. So in this sample, most of these students have really just gotten here for the first time. This is their first semester NSC. Then we have a small minority of students who have been here, 7 to 10 semesters. So if we do the math for this, we're going to find that the mean is 2.471. So that would be something that falls around here-ish. The median and mode are both 1 though. The midpoint is right here, and of course that's the tallest bar. So before we look at the answer, think about which one of those values is a better reflection of the nature of this data. Well, it's going to be the median in this case, not only because we can see it's the most accurate, but also because we're working with continuous ratio data with a positively skewed distribution. So number of semesters, that's a truly numeric value. It's ratio because you can have a true 0 point. If you said 0, you haven't been here any semesters, and you can't be here a negative number of semesters. It's also continuous because think about it, we're in the middle of the semester right now. So if this was your first semester here, you'd be here for like 0.42 semesters, right? You can be here not just a whole number of semesters if you're in the middle of a semester. Also, you can see there's a clear positive skew happening here. So again, the median would be the best in this example. Now let's take a look at a different data set, looking at the number of semesters at Nevada State College among a sample of students. So in this case, we can see that we have more of a normal distribution, less of a skew, right? Most of the students fall kind of in the middle between 5 to 7 semesters, and then it kind of tapers off as you get to the low and high end. If we look at the values here, our mean is 5.763, so that's really like here-ish. Our median and our mode are both 6. Now you will find that when you have a normal distribution, typically your mean, your median, and your mode are very, very, very close. They're all really centered there in the middle. So in this case, just kind of visualizing and thinking about it doesn't really reveal necessarily which one is the absolute best. So let's think about the decision-making model in the flowchart that I gave you. So in this case, the mean is the best measure of central tendency. And that's because we have continuous ratio data with a roughly normal distribution. So, all three of these are pretty close, but remember, if you can, you want to use the mean. That's the statistician's favorite measure of central tendency. And also we know we've got ratio data and it's continuous. Already discussed why that is. And this time we have a roughly normal distribution. So the mean is what we'd go with in this case. Now let's look at another distribution of sample of students from Nevada State College, seeing how many semesters they've been at NSC. So in this case, we have a bimodal distribution where 1 and 9 are by far the most frequently occurring values, and everything else is kind of low frequency compared to those two. In this case, our mean would be 5.570, so that would be around like here-ish, and let's make that line a little smaller here, like here-ish. And then our median would be 6. So our mean is like, our mean is like here. Our median is right here. And if you think about that, looking at the trends in the data, think about how accurate that would be to describe it. Then we've got our mode of 1 and 9. Bam and bam. So just looking at this, not thinking about the flow chart, which way would you want to describe the data to be the most accurate about the nature of the trends in the data? Well, in this case, the mode is the best measure of central tendency because it really reflects those huge spikes in number of students for those two numbers of semesters. Whereas the median and the mean kind of make it seem like, most students have been here about 5 to 6 semesters, but that is not the case. Also, if you follow the flow chart, you'll see that number of semesters, again, continuous in ratio, just like the previous two examples, but now we have a bimodal distribution. So you would want to report your modes in this case. So now let's take a look at a new example looking at a new variable, which is LAS major. And this is actually based on real data that I got from the NSC dashboard, which I encourage you guys to look at. It's pretty cool. If you click on the NSC website about NSC and then facts and figures and institutional data, you can look at all kinds of really cool data about our students here. So if we look at this LAS majors, we can see that clearly psychology is the most popular major among LAS, followed by business and biology. Also, you'll see that, it's just kind of all over the place in terms of, the different number of students. Now, think about it. Can we compute the mean? If we added all the business plus biology, no, because those aren't numeric values. So the mean is out. In this case, our median, our midpoint is criminal justice. So our median, our midpoint would be like right here. Is that meaningful though? Probably not, because I could make this graph look however I want, right? I can reorder these categories along the x-axis in any way, shape, or form to come up with any shape I really wanted to here. So that midpoint isn't meaningful at all. So the only thing that we're left with is our mode of psychology. That is the most commonly occurring major. Now, I'm not going to report business and biology just because, they're pretty close and this psychology is way above and beyond the rest. So again, the mode is the best measure of central tendency. And even if you didn't think about the logic behind that decision, kind of what we just did, you know that this would be the case because we have nominal data. So you don't even ask yourself the shape. As soon as you figure out you have nominal data, something that's categorical, can't be placed in meaningful order, you jump straight to the mode. Let's look at this one. See how I manipulated this data? It's the same exact data, but now magically it's in a normal distribution. Also notice that in the previous examples, we had histograms because we were working with interval or ratio, specifically ratio data. Now I'm showing you bar graphs because we're working with nominal or ordinal, specifically nominal data. So when you're doing your lecture quiz, feel free to use the displays of data as a little hint for yourself about scales of measurement. So again, we're looking at major. Can't compute the mean, we don't have numbers. The median is business this time because I've reorganized my data, but yet again, it's completely meaningless because this isn't a meaningful order that you can place values in on the x-axis. So again, the mode is psychology, tallest bar, and that's really what we're left with. The mode is the best measure. Again, it's nominal data. The shape is irrelevant. If you see a normal distribution, don't jump straight to mean. Think about that flow chart. The first question you have to ask yourself is the scale of measurement. And if it's nominal, you're done. You're going with the mode. So now let's look at a different example, looking at class standing. And I actually pulled this from the dashboard as well on NSC's website. So if we're looking at this, again, it's in a bar chart, so you know that it is nominal or ordinal, right? Specifically, it's ordinal because there's a meaningful order here, right? Freshmen have been here the least amount of time, seniors have been here the longest. Yet again, we can't compute the mean. What's the sum of x? I don't know. If we change this to number of semesters, right, instead of looking at the categories of class standing, then we're talking about a different story. Then we're kind of looking at the data we looked at previously. But since we're limited to these categories, that they're in meaningful order, but they're not numeric, we can't compute the mean. The median in this case would be junior, and the mode in this case would be senior. So let's think about what's the most accurate way to describe this data. What's going on with these students? Like what is the typical class standing? In this case, the median is the best measure of central tendency. This really isn't that outstanding, right? That mode is not that much higher than the rest. Also, if you think about it, right, if we say senior, that's going to kind of not get at the fact that we've got some freshmen and sophomores here too. Also, if we think about this, if we think about our flow chart, this is ordinal data. And as soon as you know it's ordinal data, you jump straight to the median. So just to reiterate, when you have a normal distribution, your mean, your median, and your mode are always going to be the same, assuming you have numeric data, right? If you don't, then you're not going to be able to calculate the mean, and the median may be meaningless. But as long as you have numeric data, your mean, your median, and your mode are going to be very similar if you have a normal distribution. So although all three are going to give a pretty accurate picture of the data because they're all similar, you go with that mean because that is the most preferred measure of central tendency. If you can use it, use it.